Welcome everybody to Hyperledger Ursa's Building Secure Protocols. So I'm just going to go a little bit about myself. So I work at the Sovrin Foundation. I do a lot of their security stuff, designing, research, publishing, and anything related to security I enjoy. So that's what I get to do there. So that's a little bit about me and how I got involved with Ursa. I was with Hyperledger Indy and then Aries, and then when those Ursa got spun off, I kind of went with that route because I was working with all of the security layers in Indy, and Ursa started off with a lot of the original code from Indy, and now it's in Ursa for everybody else to use. So I'm a maintainer in Ursa, but I also contribute to Indy and Aries quite regularly.
My name is Brent. I work for Evernym. I do cryptographic protocols. Privacy is my main interest and my main concerns. I do some software architecture, and they also shoved me into standards development. I don't know what that says about how much they like me, but in addition to doing some Ursa maintaining and Hyperledger contributing, they've got me working at the W3C. We're working on decentralized identifiers and verifiable credentials and all sorts of fun things. All right, we're going to talk about a few things. Mostly we're going to be plugging Ursa and why you should be using it and why you shouldn't be using some other things. To start off, Ursa is a common crypto library. It was spun out of Indy, but it is common code, and it's intended to be used by any Hyperledger project that can, and any project outside of Hyperledger that wants to. It's open source, it's public. Ursa is a collection of well-vetted algorithms. We're not inventing new crypto. We're taking papers that have been well-reviewed and analyzed and implementing them so that people can use the techniques that are described there. They were implemented by people who have been trained to implement cryptographic algorithms and protocols. The code has been reviewed by cryptanalysts and cryptographers. And there's an active developer community, so if there's something wrong with the code, we've got people who know how to fix it right there ready to fix it.
And you know we don't write anything broken.
No, yeah, right. Some of the things you can do with Ursa: you can encrypt things, you can do integrity protection, you can do digital signatures. We can do really fun stuff like verifiable and anonymous credentials. We have zero-knowledge proof stuff that we're building in there, ZK snarks and bulletproofs and all sorts of really fun, cool, cutting-edge, leading-edge cryptographic things.
Okay, so the first rule of crypto is don't roll your own crypto. I don't know if you've heard that a lot, but we'll be preaching that you should never try and do this yourself. I like to think of it as you doing surgery at your house, and how many of you would ever try to attempt that? It's very dangerous, even for those that know what they're doing. So don't try and do it yourself. And given how many security attacks and things happen, you know that it's just plain hard to do it right in the first place. And so one of the great things about Ursa is we try to aggregate all of that in one place. These are some common things that typically happen if you're trying to roll your own crypto libraries. You could just implement it completely wrong, or you accidentally expose the private keys in some side channel attack, or the crypto analyst finds something wrong with the math that you've written yourself. It's just weak at the math layer. So don't ever try and do it yourself. Always do it under trained professionals. And the thing is, if you're designing crypto, we hope that you have a PhD in cryptography, or you consider yourself a cryptographer. And if you're implementing it, don't consider it production ready until it has been peer reviewed by many others, especially with the cryptographer that wrote it or invented it. That's very important to know. And things still can go very wrong when you know what you're doing. So, I mean, Apple, for example, had 2 known attacks, and think of the resources that Apple does when it's employing and writing cryptography. So it had an attack with iMessage where even though they were employing state-of-the-art crypto, an attacker could still insert himself and decrypt all of your iMessages, or with their file decryption, encryption library called REncryptor, which they have now fixed. Even though they were encrypting it using a secure algorithm, an attacker could still just safely decrypt the file, even though it was safely protected, right? So the thing is, yeah, what, did I skip a slide? Yeah, there we go. So if you look at these other libraries, some of them, they've tried to invent their own crypto, and others, they've been widely used, and they still have things that have gone wrong. So at Real World Crypto this year, they were really harping on the Moscow internet voting system, which they just deployed, where cryptographers were advising them, there's insecurities in what you've designed, don't do it, and they went forward with it anyway, hoping that their votes can't be tampered with. But anyway, things happen. The U2F FIDO version 1 had a bug where it allowed backdoors, even though it was reviewed and extensively reviewed by those in the security space. I mean, you can look at Intel. As hard as they've tried, things happen. So IOTA and OpenSSL.
Don't invent your own hash functions written in trinary.
Yeah. So things happen. So why is my thing not working? Oh, now it's working. So the thing is, those of us that have been in the space for a very long time, even our entire lives, it's still hard to get it right. And so if you want to work with crypto and security, it's best to leave it for those that specialize in this space. And if you have any doubts or concerns, you ask those that have been working in that space. And that's one of the great things about Hyperledger Ursa, is that there's a lot of resources devoted to this space. We've got cryptographers, we've got people that have just been working in it for a long time. So we always state that Ursa is trying to do cryptography the correct way, in that we're not rolling anything new. We are taking what's been well vetted and we are implementing it with trained professionals under a trained system that hopefully should limit badness.
Ursa is very visible. It's an open source library. Anybody can look at the code. Anybody can read the papers that the code's based on. We invite this visibility because visibility equals security. And we're aiming for Ursa to be as secure as possible. Discovering vulnerabilities in a library is a good thing. That means people are looking at it. That means people are using it, as long as those vulnerabilities are then addressed. Every crypto library is going to have some vulnerability somewhere. And Ursa is set up so that on the first hand, we're trying to avoid those. And on the other hand, when they come up, we have the infrastructure in place to deal with them. Projects that use Ursa can benefit from this. You don't have to create a signing algorithm. You can use the one that's already been implemented and vetted.
Yep, just push it.
All right, so if you use Ursa in your Hyperledger projects, you're going to have a higher level of trust and security. One of the reasons is because Ursa is written in Rust. For those of you who's used Rust before? Right, Rust is awesome. One thing that's nice about Rust is that it is secure. It was designed from inception to be memory secure. All of those horrible problems that are still happening today because of C code are impossible to do in Rust. The language won't let you buffer overflow, and it won't let you leave memory just hanging out there for anybody to read. It's also portable. You can compile it so that all of these programs that rely on legacy C code could just swap out and use something written in Rust. Servers, desktops, mobile. And Rust, because it's a lower level language, allows it to run very quickly. When you're vetting crypto, I love that we used crypto this entire time and everybody just knows we're not talking about money. Sorry.
Or other things.
Yeah, pseudo money. What algorithms does it support? Who wrote it? Has it been audited? Who's using it? If you want to grill someone who claims that these things are safe, ask them things about, is it constant time? Is it side channel resistant? Does it zero with sensitive data? These are all things. These are all things that we have done our best to ensure are in place in Ursa. There's an analogy to this. A friend of mine is a tattoo artist, and she is often asked how long she has been tattooing people. And every time she's asked this, she says, that's the wrong question. Because there's a guy down the street, he's been open for 15 years, but he only does one tattoo every 6 months. She says, I've been open for 4, and I've done more than 1,000 tattoos. So there are important questions you need to ask. If you are using Ursa, does that mean you're secure? This depends on how you think about security. It's important as you develop your protocol and determine what cryptographic tools you might make use of, that you change your mental model away from what the tools guarantee to what your protocols can guarantee. So saying things like, hey, we're good because everything is encrypted with 128-bit security from Ursa. Okay, that's great, but if you're not using it correctly, you're still not going to have a secure system.
As we saw with Apple, who said, yeah, we're using 256-bit security, and yet an attacker could still get at the encrypted data.
So it's important, even on top of choosing the right crypto library, to design things according to your threat model. And so to help differentiate here, we talk about security, security, security. My focus is privacy. You can very securely abuse people's privacy. You can send their private information fully encrypted, and only the person that you're sharing their private data with can get it. That's not either one of these is not a full answer. So you need to design a system that meets your definition of what privacy and security you're aiming for, and then do your best to prove that you've met that threat model. One example, we are often asked, is Ursa FIPS compliant? And we have to say, what do you mean by FIPS compliant? Because there's different levels. Is it compliance? Is it validated? Have the components been validated? Is it using validated components and practices? Is it using only the approved algorithms? Has it been NIST certified? At which level? These are all concerns, and when most people are like, well, I don't know. We're like, well, FIPS validation is something that, well, no Hyperledger project is FIPS validated.
That we know of.
That we're aware of. There are movements toward that, and FIPS certification is certainly a good thing, but asking this question isn't possibly the most useful of questions. You need to do some threat modeling. This is just an example here. You say, okay, here are the possible threats that we're concerned with. Here's the damage that we estimate they could do, and the probability of those attacks actually happening. So ransomware, potentially very damaging. 25% probability. We pulled these numbers out of nowhere, so this does not represent reality in any way, because every project has its own threat model. For example, something like a smash and grab, they come in, they steal some stuff, they've done a lot of damage. It's pretty unlikely that that's going to happen. So you multiply the possible damage by the assumed probability, and you get this risk score. This helps you to know what to focus on. It also helps you to, the threat modeling is also kind of an interactive process, because depending on the library that you use and the capabilities that it enables, some of these things might not be as damaging. And we're actually going to talk about that a little bit.
Okay, so the idea of when you're designing protocols is to limit the risk that you are willing to take. So there's different things you can do. Most people just want to mitigate the risk, right? You don't want to pass off to somebody else unless you can afford it. That's usually an insurance thing. So you either have to say, I'm not going to be in this space at all, or I've got to mitigate it, or I'll just assume the risk. So most people don't want to just assume the risk. They want to reduce it. So One of the things you can do with Ursa is this idea of anonymous credentials where, and I'll show you some examples later, where you can push the data out to the clients or the end users, and you don't have to assume that liability yourself. And the protocols that you can design with it enable privacy. They enhance privacy by reducing correlation. So just because I'm an anonymous person that shows up at the gym every day doesn't mean that they know, hey, it's the same person every single time, right? Because of my behavior patterns. So there's ways that we can try to reduce that. And then the great thing is, when the data is shared, you have stronger guarantees about that data because it's coming from a trusted source versus just garbage in, garbage out, which can happen. When people say, please fill out this form, they can write whatever information they want on that form, and there's no way to verify that that's where it came from or it was even legitimate. Go ahead. And so when you're collecting data, you have to think about what kind of data you're collecting. Because you have different rules about how it's handled and can be processed. And so the more data you collect, the more liabilities and laws you have to worry about, especially in Europe. And most of us do business with Europe, and now GDPR is a big one. And I read about a breach that happens just about every single day. And if you can limit the data that you have to collect to do business, just think about the data I absolutely need to do my business. If I could push the rest of it out to the edge or somewhere else and it would still be trustable and high quality, then that helps limit my liabilities if this data were to be stolen. So one way we do that is using anonymous credentials and zero-knowledge proofs, which is a verifiable credential. You can think of it as in your driver's license or in your wallet, you have different credentials that do different things, and you use them in a specific way. So with zero-knowledge proofs, I don't have to disclose necessarily everything in there, just enough for the verifier to trust me, and I can retain the rest so that the amount of data that we're sharing as a person who's presenting, I have the option to hide some of it or withhold, and then the rest of the verifier can decide what they want to do with it. Okay. So in today's world, this is kind of how credential systems flow, right? I go to a bank or some business and they ask me to create an account, which is a pain in the butt because now I have to keep track of yet another username and password and also give my data to yet another company, another copy. And then they store that information, and then there's the two types of people that can actually access it. You have a curious but honest person. Maybe it's part of their job, but maybe they're just in the business, they're a system administrator, and they're just looking at the data. They can see it, regardless of how it's being encrypted, right? The security is there, but the privacy may not be. And then there's the malicious person who hacks in and steals that information. Even though it was protected, he happened to get in through a secure channel vulnerability that may have been there.
And they have the desire to do it because that database of accounts has more than just my information in it. It's got all of the customers in it.
Yeah, I mean, you rarely see that an attacker breaks into mom and pop's flower shop because they have very, very few accounts. They go for the big high-value targets that have millions upon millions of information that can be stolen. Okay, so here's one example of how Ursa is being applied in Indy and Aries here at Hyperledger. So we've kind of talked about anonymous credentials, but in this scenario, the main thing that they're interested in when you log in is they want to know, are you the same person that visited me last time? And then if you are, I need to know which data belongs to you so that I don't accidentally share somebody else's and violate their privacy. That would be bad. So in order to do that, we need to know who you are and what you need from us. What services are you going to be asking for, right, when you're logged in? Okay, so in an anonymous credential system, here's what you would do. You would typically create an account. You would give them this is one example. You don't have to do it this way, but there's some information that is exchanged. So in this case, I just said, okay, the person's creating an account. They're going to give them their first name, the last name, and all the other information they did before. But now the company instead just stores a unique identifier and signs a credential that they then give back to that person. So you notice they didn't store anything about the person. All of that got pushed to the edge in this simple scenario. And a unique identifier is how, if this person shows up again, they know who it is. And you might say, well, how does that work when they go to present? So, for example, maybe after they issued the credential, the company says, hey, we could do a lot more business with you if you would share your phone number and give us consent to store that. And so they say, great, I'll just share it. In this case, let's say it happens sometime later. They say, I'm going to share a proof. This is the credential you gave me, but the only thing you get to see is the unique identifier and a phone number. And they can verify it because they signed it. But the honest but curious system administrator, now the only thing he sees is there's a unique identifier and some phone number, and that's all the thief can get at, is this limited subset of data. But then let's say the person wants to now go use this service. They just need to sign in, and in order to do their transactions or whatever the case may be, I want to look at my bank account or my data analytics. And in this simple scenario, the only thing they have to prove is that they have one of these credentials that the company gave them, and nothing else is disclosed, even though they signed a whole bunch of other information in there. They're just saying, I am XYZ ABC, and they're in. And that's how it works.
So Indy uses Ursa to provide this easy-to-use anonymous credential deployment system. Ursa makes that possible. Aries makes it a little easier to use. That's to differentiate between these different projects. So Indy is the backbone. Each of them has an Ursa component in there. So the full system, so the Indy and Aries portions are running Ursa. The companies rely on Indy as the blockchain backbone to store the public keys. And then Aries packages up the communication so that it's private and allows for an interoperable wallet to store the keys and the credentials that both the company and the end users can make use of.
Okay, so if I had to say this is what you should learn from this talk is don't design for, these are the encryption algorithms I'm using and we're going to be secure. You need to think about what are my guarantees that I absolutely need for my system, and then pick the tools and the processes to help you implement that system in your protocols. So the tools that you're picking should definitely be peer-reviewed. They should be standard ones that hopefully others are using and not homegrown in your own companies. And then definitely ask help from people that have been in the space and they're considered experts. And by all means, please use Ursa so that you already know one library that's been doing that. So,
any questions?
Any questions, yeah.
So there will be probably a lot of developers who do not have any cryptographic backgrounds, and they would go for the average project. I mean, is the level of abstraction sufficient enough for them to be secure and do not require for somebody from a cryptographic department to review their code?
How's Ursa's API, Mike? Is it friendly?
The Ursa's API was designed to be, user-friendly. That being said, whoever is going to be using it needs to have some security experience, right? They need to know this is an encryption algorithm that's protecting my stuff and not a signing algorithm. So they will need some security, but as far as if I pick it with this and this and this and these combinations, is that going to be secure? A lot of that's been taken care of. So it's just easy to use and misuse resistant. So it's hard to screw up.
And the nice thing about Ursa being an open source, active community is there are resources. We have a meeting once a week where we're talking about what direction we want Ursa to go to. It's a public call. Anybody can jump on if they have questions about using it. So,
yeah, and we're available over Rocket Chat to answer those kinds of questions. Oh.
What should those of us who are not developing Rust do? So we're a Golang shop, and so what I've done playing with Ursa is write a C Go tie to the C library.
Mm-hmm.
And in your thoughts, is that a reasonable way to do it?
Mm-hmm.
yes.
Yeah.
We understand that using the CGO has some drawbacks for.
It makes me a little pleased.
Yes. And you lose, I think, a lot of your fun,
Tooling.
handy Go tooling potentially. But yeah, the CGO connection is.
It works.
Yeah.
It works, but I worry, could I be leaking something there? Could there be something that I don't understand?
No, to my, it's just as secure. It's just the developer experience maybe isn't quite as wonderful as just using pure Go.
Now, if you're returning keys back from Rust into your Go code, that's a different story. For example, you're in charge of that. But when we were trying to pick a language to develop Ursa, the reason we chose Rust was, one, there was all those things that Brent mentioned earlier, but two, the portability. Rust does compile to a C callable library, and most other languages can use that. So we would write once, and everybody else could use it without having to implement it 10 or 20 different times.
But fun fact, Ursa also compiles into WASM now, which is so cool.
Yeah.
So I think we're moving left to right.
Could I have a quick related one to that?
Yeah.
Sure.
One of the things we discovered was we're doing Python, so we're doing Aries stuff, and one of the things we found is there's a Python, I don't know whether it's a Rust library for Python or there's another way, but it allows you to interface directly to the Rust, so that things like the memory save, you don't have to take the element out of Rust, put it in Python, and then have to clean up the memory.
Like an FFI interface?
It's different than FFI because Ursa has an FFI interface, but this is even simpler than that.
We're using it beside FFI, so we don't have to call out to C. We can actually just in Python pass references around. It stays in Rust. That's interesting. It's cleaned up. So you might look for that. It really was fascinating to find.
Maybe there's an equivalent for
Yeah.
Or hopefully there will be soon.
Thanks.
So I saw a hand. Did you?
So, sort of a continuation of your previous question. Will you support Go bindings, so bindings to other languages that so that we can use Ursa from within a chain code?
That's a great question. I mean, like if somebody wanted to maintain a Go binding, for example, or a
Yeah.
Python.
We accept PRs. Yes.
I'm not. I haven't been in Go in a couple of years, but yeah, we would. We've
Yes.
made it so anybody could wrap it in Go and could use it that way if you wanted.
So.
I heard that Ursa reduces security risk. So, do you plan to use Ursa support not only cryptography but also other security technologies? For example, malware analysis, malware network analysis, and so on.
I didn't catch the last thing you said, and I'm sorry.
Do you plan to support Ursa not only cryptography but also other security technologies?
I don't think we have any plans at this point, but if people want to jump in and propose that as a way forward, we have a call once a week where we talk about the direction that Ursa is going to go. The joy of being an open source project is that if there's interest enough for people to do that and build that.
I mean,
Yeah.
one thing we are working on is secure keys, like a common API. If you wanted to interact with multiple different hardware enclaves, we wouldn't be abstracting away the hardware enclaves themselves in the sense that you don't know what you're getting under the hood. It's more like if I want to design for an Intel SGX or ARM, then I can use the same code because the API looks the same. And then I can get the attestations and the guarantees outside of Ursa somehow, but at least there's some common libraries. So, I mean, that's probably about as close as you would think. A lot of the security protocols, those are in Ursa in terms of, for step one, to talk to somebody, how do I do that, and what are they supposed to send back, and those kinds of things.
So the combination of the hardware security or hardware security, those are
Yeah.
So I'm interested in Ursa in Sovrin, like facility running compiler. In order to do that, I would use Ursa as a running model.
Yeah. Yes.
Yes, it compiles to WASM.
What would have a with an export of WASM export, not a
So when you compile the WASM, it gives you two artifacts. One is a .wasm file, which I believe runs in the browser, and then there's the JavaScript library that you use to call into it, right?
I'm trying to call directly from WASM, compiler. So if you do WASM, it would go from WASM to WASM.
Now you're outside my area of expertise. I don't know I'm not a WASM person.
Mine as well. I know that we can have a WASM build, and that's very
Yeah.
exciting. I don't know exactly what you can do with that.
Is there a WASM person, Mick? You're laughing. I don't know if that's possible. Maybe you're a WASM expert. Okay. So hopefully that helps.
So I'll let Mike answer as well. OpenSSL, have you ever seen the Swiss Army knife that's like that big and doesn't actually fit in your pocket anymore? That's the OpenSSL model. We want to be able to do everything in every way and allow people to configure things however they want. And Ursa attempts to be much more constrained. So there is less of an opportunity to shoot yourself in the foot when you use it. So that's my 2 cents.
The second thing is there are certain things that OpenSSL does not do. Like it does not do the verifiable credentials. It doesn't do zero-knowledge proofs. And it's written in C. And if you want to compile it, you have to have a Perl interpreter. So if you don't want a Perl interpreter and a C compiler, then sure. But I mean, the main thing is the misuse resistance, and then 2, the zero knowledge proofs.
Largely because, well, subsetting it out, but largely because it's everything in there has been there forever. Some of the stuff that Ursa is trying to do, some of it's not quite so much. How do I differentiate what my expectations should be for the security?
So we do attempt to document what those features are and the guarantees around them. So for example, anonymous credential signatures, some of them have been around since 2001 and they've been well vetted. Some of them are a little newer, like 2012. And we do reference those in RFCs in the papers about kind of the guarantees you get using, if you want to use these. Does that help? Okay, yeah.
I just need to soapbox briefly. It always irks me when people say it's new crypto, because if you've gone on the internet today, you've used Diffie-Hellman, and the cryptographic guarantees that Diffie-Hellman relies on are the exact same guarantees that most of the new crypto in Ursa relies on. I know what you mean. I accept your quibbles. Right.
Right, just like we described.
In your implementation, so I'm not a cryptographer, so it might be a stupid question. Do you have any major concern for the post-quantum threats for the cryptography? Because I know that, of course, I mean, OpenSSL definitely in some areas is not quantum ready, but even in the zero-knowledge groups, I know there are some implementations which claim to be post-quantum ready, some are not. I mean, do you
Yeah, we're very aware of those. So Hart Montgomery back there is a cryptographer that he's part of the Ursa committee. He specializes in post-quantum. Is that correct to say, Hart, or am I just throwing you on the spot? Yeah, okay. So that being said, we probably have talked about it at least half a dozen times. So if you're concerned about quantum security, post-quantum security, you can definitely try to figure out what's the best, but the thing is there's still the competition about what should be approved and what isn't. I mean, even NIST doesn't know what's the best way to protect against that yet. And so when they decide what's best, then that's when we were going to take another stab. And that should finish sometime this summer, right, Hart?
Second round finishes this summer.
Yeah.
There will be at least 3 rounds.
Yeah, so I mean, if you're that nervous about it, one thing we've suggested to people is use the current crypto system that you know is tried and true, and then pick a quantum one that some security experts recommend. Use them both at the same time, and then if a quantum computer actually becomes feasible, then even dating back to whenever this was done, there's the quantum way, which was safe. And a lot of the algorithms we use, some of them could be broken when quantum comes out. Some of them probably won't be. So like, for example, the zero-knowledge proofs, if a quantum computer comes out, they would not be able to reverse the proofs that have already been generated. So those are considered quantum resistant, unless an algorithm was invented that could reverse those. But new proofs, you would not be able to trust because they could be forged.
I guess to sum up, we're doing the research to try to figure out which direction to head as far as post-quantum goes. The goal with Ursa is that when it becomes a problem, implementers should be able to seamlessly swap it out because you should have written it to the same interface. So you use the same front-end interface on the back end, you can use the new fancy post-quantum stuff that isn't
and we've
implemented
made
yet.
Hopefully the best decisions that with equal guarantees.
Any other questions? You guys have been fabulous.
Again, okay, do you have any roadmap for zero-knowledge proofs to become a library for, and not necessarily ZK stacks, but like new stuff?
What's in it?
That came out like AdStat or Info.Info. Are you looking into including those?
So the zero-knowledge proofs we currently support is doing zero-knowledge proofs for set memberships. Is something in a set? Is something not in a set? Is something in a range between an X and a Y? Selective disclosure, which is what's used by anonymous credentials. In terms of adding new ones for like Mimblewimble, probably not Mimblewimble. We've definitely been looking at snarks. And right now,
snarks, starks, stonks, plonks.
Yeah, I mean,
every few days there's a new fun acronym.
Yeah. So trying to decide which ones make sense to put in there and which ones don't. But that's part of the discussion of the calls, is what makes sense in terms of what is the value add? Is it making it so that the proofs are faster and smaller or more secure? What's the purpose of it? So we are still evaluating which snarks make sense to do. Bulletproofs are already in there. Bulletproofs for set memberships and ranges are already in there. And part of the reason we went that route is there's no, if you're ever familiar with snarks, they have what we call a trusted setup problem, which means you have to trust whoever created this. It's the same issue with some of other crypto primitives, but with bulletproofs, we don't have that.
Yeah, so with the zero-knowledge proof technology, especially the circuit-based technologies, we're aiming for that middle ground of cool and functional, but also still usable. It was as awesome as Zcash is. It's one of my favorite projects. It took years. It's taken years for their zero-knowledge proof ZK snarks library to actually be efficient enough to be usable regularly. So we're aiming for that, usability over the coolest, newest, bleeding edge stuff.
When you're saying that this library is applicable to Hyperledger projects, does it mean that like developers of Fabric or any other Hyperledger can use your library, or is it like a library for a generic usage?
You could use it generically if you wanted as well. I know Transact shimmed it in to use it for some of their digital signing as an optional digital signing tool. Aroha did the same thing, and I'm trying to remember the other one. Might have been Grid, but
yeah. So its original inception was as a library for use by other Hyperledger projects, but it's certainly not limited to that.
Mick, you've been sitting there. No, it probably takes someone who's motivated to swap it in for something. The APIs, it's integration.
Integration and communication. Because a lot of the projects haven't jumped in and said, hey, if Ursa did this, then we would use it. It's that did this answer that we would love to implement. We would love for it to be the primary cryptographic capability of all of the Hyperledger projects. That's kind of the goal of it.
I mean, like, for example, Indy hasn't been 100% on Ursa. It's using a lot of Ursa, but there are some features that says, hey, if you just added this, then we could use it for everything. They're the only ones that have openly said that. None of the other projects have said, hey, if it supported this, I would use it. It's more like, what do I need to do to get it in there? So the APIs are pretty stable, and the tool is pretty stable in terms of using it. They just need to take the time to do it. So like I said, there have been a few others that are using it already, but part of the reason we moved a lot of the crypto code into Ursa was so it could be broadly adopted. The zero knowledge proof stuff is probably the most value add that people want. That would probably help, because none of us are Go experts. I've coded in Go in the past, but I haven't touched it in a while, and I'm sure the language has moved on since I last touched it, because most languages don't stay stable or stay static. So Go binding would be another one. I know Python is a big popular one, but usually those that are already C-callable, like the dynamic languages like Ruby and Python, it just works, and Node.js. But yeah, C-Go is a little more, I think, involved. I know there's some that are trying to use it in C#, and that one's not too hard to do either. So.
But yeah, if there were C bindings that allowed Go libraries to use Ursa natively, that would be fabulous.
I didn't hear what he said.
I also did not hear what you said. I'm sorry.
So what did you have to review past the implementation on the ground?
Oh, what reviews? To get it audited in terms of what? Just an outsider to, like another firm, to just look at the algorithms to say, hey, everything looks good. So we have had quite a few cryptographers. So a lot of zero knowledge proofs in terms of credentialing was the cryptographer's name is Jan Kamenisch. He currently works at Dfinity, used to be at IBM. His team has looked at those algorithms and found very low risk things that we've already fixed. Is it Netitude? Or I can't remember. It has looked at it and audited some things, and we've fixed those. So, and then some of the other cryptographers, Dmitry Hovratovich has vetted it. Hart frequently, whenever we write crypto code, will sit down and review it with us to make sure we haven't done anything stupid. So in terms of that, yeah, in terms of a formal review, it depends on what you're looking for. To just say there's nothing insecure in it, well, it depends on what model are you trying to design against. So are all the libraries secure against backdoors? Great. Yeah, that's, we can audit that right now if you wanted. A lot of security reviews are quite expensive, and so any company that wants to pony up a couple thousand, $10,000 or $30,000 to do the audit, great. We'd be totally involved with that, but they are quite expensive and time-consuming to do.
So I just looked at my watch, and you guys don't need to wait here and listen to questions if you want to go eat lunch. But if you have more questions, you're more than welcome to continue asking them. But
we'll stay as long as there's questions.
I'm not offended if you guys are like, I'm hungry, because I'm also hungry. So let's get more intimate and come up.